Hello, uh, welcome at this platform. My name is Mohammed Sabir, and today's class I will start a new topic. The name of the topic is vector. Okay, first let's change the color of the pen. Okay, and in earlier classes we have studied about differentiation, integration, and it is the last tool to understand physics, and then I will start a proper physics course. Okay, and you know about a vector. I think first write the name of the topic. That is a vector. Like in a physical era, we have two type of quantity. First is a scalar, another is a vector quantity. First is a scalar quantity, and another is a vector quantity. Okay, this is the basic classification of a physical quantity. Okay, and now the time to understand how we can understand a scalar physical quantity and how we can define the vector quantity. Scalar is something you can say when you know about a temperature. Okay, a temperature is a scalar quantity because it is not required to define a direction. It is not required to define a direction. Okay, and in case of a velocity, a magnetic field, electric field, without direction, uh, there will be no meaning of that physical quantity. And that's why the direction plays an important role in a physical world, because only magnitude is not sufficient to define a physical quantity. Okay, and like mm, you we actually we plot some spectrum of physical quantity. You can assume, you can understand what type of physical quantity lie in a scalar and a vector, because dealing with a physical quantity, dealing with a scalar and vector, they are so different mm, method, because scalar quantity is simple, follow a algebraic rule, but in a case of vector, we have to restrict on a algebra, like a mathematical matrix rule. And you also can say we have to also define extra mathematical operations. And that's why we have to focus on, we have to understand how to add a vector quantity, how to add a, how to subtract, how to resolve, and this type of question we can easily answer. Okay, and in a physical quantity, in a scalar quantity, this is a scalar quantity. Scalar is something, the temperature is a scalar quantity, and a pressure is a scalar quantity because it is not required to define a direction. Okay, and a pressure on a distance, and these are the some example of a scalar quantity. And move to the let's move to the vector quantity. What is a vector? A vector is something like magnetic field, magnetic field or electric field, because without direction it does not fulfill on meaning. That's why we have to define a direction. That this is a, this is a electric field. like we say electric field has a strength or 30 newton per coulomb square. Now the question is that uh, in electric field, a charged particle is there, and now the question is that what will be the magnitude of the force which is experienced by this charged particle. And one other question is also there, that is the, what is the direction of a force which is applied by a magnetic field on a charged particle. And that question we can answer only by using a vector field. Okay, and that's why electric and magnetic field are the vector field. Okay, and now move to the representation of a vector because it's uh, quite easy, and it's so quite easy. Okay, okay. A vector is simple. You can represent simply by a arrow. The length of an arrow gives a magnitude of a vector for that particular physical quantity, and the direction of the arrow, it gives a this arrow gives a direction of a physical quantity. You can say in a which direction physical quantity pointed. Okay, and you can represent a vector. This is something we can resolve into a direction and magnitude. AK. Uh, this part gives a clear picture about a magnitude, and this gives a this is a unit vector, and it gives a direction. It gives a direction for a vector. uh, by giving a so simple example, I will try to define how you can understand a vector in a practical manner. Okay, let's take this block. This is a block of mass m, and we apply a force on a block. uh, you can look the direction of a force, uh, like a force makes an angle theta with a horizontal, and this is vector quantity because the 30 newton is not sufficient to tell to someone कि I apply a force of a 30 newton. You have to tell what is the direction of a force which you have which you have applied on a block. Okay, and that's why the direction is so important as well as magnitude. And now, how we can represent in a Cartesian coordinate system uh, or a vector quantity. This is a simple Cartesian coordinate system, and the I and J and K. You also can say the X and Y and Z. Unit vector in a direction of a X, and unit vector in a direction of a Y, and unit vector in a direction of a Z. Okay, you can simply whatever quantity have is a coordinate of a this point, you can easily write out r vector is equal to xik plus yjk plus zkk. Okay, this is so simple. I think you are able to understand what I want to convey with you, and that's a so simple example. Uh, Now the question is that how we can represent this force as a vector quantity. This is f vector. Okay, simply you resolve into a direction of x and y. This is so simple, and it's a some basic rule is there. You can refer NCERT for this because I'm not focusing on the basic uh, application the mathematical part. You can refer for NCERT. I'm focusing on the how to apply the concept of a vector. Okay, how to define a vector and how we can apply. That's a main question. Let's change the slide. Okay, and this is so simple. I think you can represent. Now move to the dot product and cross product. And dot product and cross product. Dot product and cross product. A dot product is something you can say it's a so simple mathematical operation. It's not a fundamental rule. Whatever you want to define, you can define. But scientists and mathematicians define such a manner A dot B, A dot B is something, a magnitude of A and magnitude of a B are the angle between that vector. Okay, this is A B cos theta, and it's give a clear picture about a work done. Like there are so many physical quantity follows a dot product to like a work done, and like there's so many power and a cross product because it's give a scalar physical quantity, and a cross product is something like when we A cross B is something A magnitude of A magnitude of B and sine theta and n k. Okay. What is n k? It's a unit vector in the direction of perpendicular to the plane which having a vector A and B. And this is A vector, this is B vector, and this is a theta. Okay, like uh, we have to find out the direction of a and k unit vector. How we can find? First, you have to use a right hand uh, palm and uh, rotate the palm such a manner it moves A to B. Okay, it rotates such a manner A to B. Uh, the thumb gives the direction of a unit vector. Okay, it's so simple. It's quite easy. You can easily buy. You can easily understand. Okay, now move to the next slide. Uh, this is like I will give two example of a for a dot product and a cross product. Okay, let's okay. Now another thing is that about a dot product, I will give some practical example to understand how we can understand the dot product. I think let's focus on our we define a physical quantity. This is a work done. Okay, a work done is something the force vector, a dot, a displacement vector. Okay, and this this whole product result gives a scalar quantity that is a work done. And another thing is that this is a cross product. A cross product. What is a cross product? A cross product is something I think you know about a Lorentz force, Q V cross B. This is the electric field, this is a magnetic field B vector. Okay, and a charged particle having a velocity v or vector in this direction. And now our purpose is to find out of uh, what will be the direction of a force which is experienced by this particle due to the magnetic field. By using a simple right hand thumb rule, you can find out like a v cross p, uh, the direction of a force into a ball by simple this representation you can represent. Okay, and this is all about you, all about vector, and you can ask any doubt and keep learning, and thank you, all the best.